unit, we are going to discuss Graham's law of diffusion and gas laws. We have already talked about Boyle's law, Church's law, combined gas laws, and we have done questions under the respective gas laws. Now, under Graham's law, we say that the rate of diffusion of a gas is inversely proportional to the square root of its density at constant temperature and pressure. This is represented like this. So we are saying the rate of diffusion of a gas is inversely, this is an inverse, right? It's inversely proportional to the square root of its density at constant temperature and pressure. So we are going to introduce a constant of proportionality, and we are going to write it as rate is inversely proportional to the square root of the rate is inversely proportional to the square root of its density at constant temperature and pressure. So when we introduce the constant of proportionality, we are going to write it as this. Now we can also rearrange this to have it as rate is inversely proportional to the density at constant temperature and pressure. So we can also rearrange it to have it like that. Now, if you're comparing two gases, okay, if you're comparing how many gases? Two. So if you're comparing two gases, we say that the rate of diffusion of your gas, we are going to call this gas A, okay, is inversely proportional to the square root of its what? Of its density at constant temperature and pressure. So we are going to represent it as Ra for the first gas. We are comparing two gases, okay, is inversely proportional to the square roots of its density at constant temperature and pressure. Okay, at constant temperature and pressure. So this is for our gas A. Our gas B is also going to be what? The same, okay? dB at constant temperature and pressure. So we can combine these two to get a formula that looks like this. Ra dA is equal to your Rb dB. Okay, now we can rearrange to have our rates on one side, okay, and if we rearrange to have our rates on one side, we are going to have your Ra, okay, over Rb, rate A, that R is rate, so Ra over Rb is equal to the square root of dB over density, D is density, okay, over D. If we're comparing gases and the gases have the same mass, we are going to use mass in place of our density. Thus, we are going to have a formula that is Ra over Rb, R is rate, remember, okay, is equals to the square root of your Mb, your mass B, over your mass what? Your mass A. So that is it about Graham's law of diffusion. Thing under Graham's law of diffusion, we also look at the time of diffusion of our gas, okay, the time of diffusion of our gas. And what do we say about the time of diffusion of our gas? We say that the rate of diffusion of a gas is inversely proportional to the time of diffusion of a gas. When you're talking about time of diffusion of gas, the formula that we're going to use is, you're going to say Ra over Rb is inversely proportional to Tb over Ta. T is time A, okay? Also, we say that the time of diffusion of our gas, the time of diffusion of our gas, this is time versus the rate of diffusion, time versus what? The mass of our gas. We say that the time of diffusion of our gas is directly proportional to the mass of that gas. This means that gases which have a high molecular mass are going to diffuse at a slower rate compared to gases which have low molecular mass. Okay, so this is Tb over Ta is directly proportional to the square root of your your MB, because it is directly proportional, okay? MB over what? Over MA. Now, let us do a question. Have your T1. So the T1 is 90 seconds, okay? Do we have our T2? No, we have been told to calculate the time taken. Now, what else do we have? We have the mass, okay? The mass of ozone, which is going to be what? The mass of ozone is going to be, the mass of oxygen is 16, so it is 16 times 3. When you do 16 times 3, what do you get? 16 times 3 is going to give you what? 48 grams per mole. That is the mass of our ozone. And the mass of our, so meaning we have what? We have M1, okay? So this is what we write as TA, TB, MA, MB. So we can say our TA is 90 seconds. Our TB is what we don't have. Our MA is 48 grams per mole. And then what is going to be our MB? The mass of carbon dioxide is going to be what? You're going to take, so if we add the masses of carbon and oxygen, we are going to get it as 44 grams per mole. So the mass of carbon dioxide is 44 grams per mole. So the formula that we're going to use, our time A over time B is directly proportional to our mass A over what? Our mass B. So our time A is 90 seconds over time B, which is what we don't have. We can put it, so let us just write time B is equals to the square root of your mass A, which is, your mass A is 48 grams per mole over your mass B, which is 44, like that, okay? So this, you're going to again cross multiply, and when you cross multiply, what are you going to get? You're going to get 90. This is 90, yeah? Yeah, you're going to get, it is 96 seconds. Sorry, so it is 96 seconds. 96 seconds, okay? Cross multiply, you're going to get your 96 seconds times 44 times the square root of your 44 times square root of 44 is equals to TB, you multiply by the square root of 48. So once you work this out, you're going to get your TB as 91 seconds, okay? 91 seconds.